Well, we are down to pretty much our last week of regular session. It's flown by. I don't know about for anybody else, but it seems like for me it's flown by. Concluding this week, finally the algebra. And again, I put in the notes that it's kind of the basic stuff. But this isn't getting into any details. That's I think a lot of people hear algebra and they start wigging out, thinking it's something crazy, but this is just your basic intro to it, and to kind of get used to the use of variables and equations and things. So starting on page 99, I'm just going to do a walkthrough of kind of some of the stuff in the book. If I say some words funny, I apologize. I took a softball in the mouth this week, and my lip is take the gum out too, is swelled up, and I'm still saying some words funny, I think. So still feels like I have a little bit of like a Novocaine effect. Anyway, I'm tangenting. Page 99, we're starting with number patterns, and this is just, you'll see in the first few pages of this, it's very basic, simple stuff, and you kind of think like, wow, this is way too easy, what's the deal? But it's to get your mind to start thinking on lines of just the simplicity of numbers. But think when you start putting variables in, it's amazing just how all of a sudden your mind takes something like this and just completely forgets it. So you'll kind of see how it ties in, and it starts making you think like, wow, like variables aren't that hard, but for some reason when it's something you don't know, you kind of just lose track of the basic number patterns and things that are just so common to us. And you'll see as we go through. It just starts out with just a simple, things like subtract 7, add 6, multiply by 4, and you're just filling in the blanks, just going down through. So each new number, you just apply whatever the rule is for that pattern. And they start out very simple, then they get like two-step ones, nothing that hard on this page, stuff that everyone can do. Jumping over to 100, we start seeing some of the basic property of numbers. The commutative property, associative property, distributive property, properties of 0 and 1, inverse operations as you read down through. The commutative property is that addition and multiplication, if you change numbers, the result doesn't change. 7 plus 5 is 12, 5 plus 7 is 12. Doesn't matter what order they're in. When you add them together, it's the same result. Same way multiplication, 5 times 7, 35, 7 times 5, 35. Doesn't matter which order they're in. If you add or subtract or add or multiply, answer is going to be the same. And as you can see there, subtraction and division it does not apply to, because it is very important for those two which order it is in. 7 minus 5 is 2, but 5 minus 7 is negative 2. So huge difference. Same way with division. Perfect example is right there. 6 divided by 3 is 2. But 3 divided by 6 is 1/2, 1 over 2. So again, big difference in order of which things are going. And when we get into the variables, you'll see how important the wording is to know which order to put them in for subtraction and division, because of this, what you see right here. The difference between right and wrong, simply the order you put the numbers in. The associative property then goes into the way you group the numbers together. If you wrap the parentheses around and all the numbers are being added, it doesn't matter. The parentheses aren't going to change anything, because you're all adding them all together. It doesn't matter what order they're in, where the parentheses go, the answer is going to be the same. Same way with multiplication. It doesn't matter where the parentheses are and what order the numbers are in. If you have 2, 5, and 3, no matter how you line them up, you're going to get 30. It doesn't matter where the parentheses go. It doesn't matter what order the numbers are in. You're going to have 30. But subtraction and division makes a huge difference where the parentheses go in the order of the numbers. We've already seen it with the order of the numbers. As you can see in the example with the parentheses, excuse me, 5 minus 2 minus 1. If you put the parentheses around the 5 minus 2, you do that first, you get 3. 3 minus 1 is 2. But if you change that and put the parentheses around the 2 and the 1, now you got 5 minus, and you do the 2 minus 1 first, 5 minus 1 equals 4. Obviously, you get two different answers. I'm quite sure everybody knows the order of operations, that you do parentheses first. Make sure that's thrown in there just in case you forgot or have never learned that, you always do the parentheses first in a problem. And then division, same thing. If you have 27 divided by 3 divided by 3, if you put the parentheses around the first 27 divided by 3, that's 9. Then the 9 divided by 3 is 3. And I don't know if your book has a typo there, but it should be 9 divided by 3, not 9 times 3. And then underneath of that, 3 divided by 3 in parentheses, you do that first, that's 1. 27 divided by 1, 27. Obviously, you're getting two different answers. So, again, associative property. Addition and multiplication doesn't matter where the parentheses go, but subtraction and division, it makes a huge difference. The distributive property, a little bit confusing. Not too much. It's just, if you see the example there, 5 times parentheses 8 plus 2 also means you can take 5 times both of those numbers separately. So 5 times 8 and 5 times 2, and then add them together. So if you do the parentheses first, you do 8 plus 2 is 10, 5 times 10 is 50. If you distribute it out, 5 times 8, you get 40, and then 5 times 2 is 10. If you add those two together, you also get 50. So the distributive properties, and that'll come in you'll use it a lot going in solving equations, where the number outside parentheses is multiplied by both parts of number of the inside of the parentheses. And the properties of 0, just simply, that if you add or subtract, 0 from a number, the number doesn't change. That's, very common. Most people, no problem with that. And then you see there, subtract a number from itself, it's always 0. Any number subtract itself is always 0. And if you multiply any number by 0, it's also 0. If you divide 0 by any non-zero number, the answer is 0. And as you see there, you cannot divide by 0. You'll always get 0 to check your answer. Therefore, you'll hear things say like dividing by 0 is undefined, things like that. So I don't think you'd ever come across it on a test. But if you do, you cannot divide by 0. 8 divided by 0 is undefined. There's no answer. And like it says there, and the way you do that is if you check the answer, you'd get 0, and then 0 times 0 will be 0, not 8. So just one of those things to keep in mind. And then the properties of 1, if you multiply or divide by 1, you get the same thing. Any number divided by itself will also be 1. And then the inverse operations are good for checking answers. Addition and subtraction are counters inverse of each other, and the multiplication and division are the same thing. So if you problem calls for adding and you get an answer, well then you come back and subtract to check your answer. So 3 plus 7 is 10, so to check your answer you would say, okay, well 10 minus 7 has to give me 3. And then the addition or multiplication division, 3 times 7 is 21, so that tells me 21 divided by 7 has to equal 3. So the rest of that page is just you're filling in those blanks, kind of applying those rules of, what are you doing to make those statements correct. And some of those there is more than one correct answer. Even if you have the answer key, it's not listed. There's a couple typos I've noticed in this answer key, so just be careful. Flipping over to 102, the working with functions. Here, function is just basically kind of a rule that changes the numerical value in a set. As you can see there, that input-output, you have 25, and the output 42, 9, and 10. And you see the rule there is you subtract 4 from the input and then multiply that by 2 to get the output. So input 25, take away 4, be 21, multiply that by 2, you get 42. And then as you're going down through, you start looking for how to figure out, get your mind thinking about number patterns and different rules. And some of them are very basic. Some of them might take a couple minutes to kind of think like, okay, what is this rule doing? How am I getting from that to that? So next page, variables to write expression. Okay, we're finally getting into the variables. Variables simply means a letter that's taking the place of a number. The most common ones you'll see are like X, N, Y, Z. But you can see all kinds of different letters used. They're unknowns. They're used to kind of in problems to look for an answer that you're looking for in a problem. If you spend so much money on 3 different items, and you know how much 2 of the items cost, and you want to know how much the third item costs, you'd set up a variable and set up the expression to figure out that variable. We'll get to those in a little bit. But a mathematical expression, as you see there, is like a phrase in English. It's not a complete thought. It's just like part of something to get you kind of on the track to where you need to go. And reading down through them, seeing if there's anything I want to really kind of go over. Getting down to the practice, you start seeing like a number multiplied by 16. And that's just simply when it says a number, that means the variable. That means like the n or x, whatever letter you decide to choose. I think the book usually defaults to n in the answers. But so a number multiplied by 16 would simply be n times 16. Now what you'll start seeing is whenever you're multiplying by a variable, you'll just see the number and the variable right beside each other. You don't use the x because x can also be a variable, so you don't want to use x to show you're multiplying because it can be confusing because is that an x or is that main multiplication? So when you see multiplication, the note that's right above the practice things on page 103 there, it says when a variable is being multiplied, an expression is usually written without the multiplication sign. So 3 times n would just be 3n. Okay, so that means 3 multiplied by n. So the first number 1 in the practice, a number multiplied by 16 would be 16n. Okay, and usually the number's first and the variable's second. Just kind of you don't usually see n16, you see 16n. Now where these kind of get people messed up is like for number 5, for example, a difference between a number and 20. Difference always means subtraction. Now when you subtract, you have to put it in the order that the expression is written. So the difference between a number and 20 has to be n minus 20. Okay, if it said the difference between 20 and a number, then it would be 20 minus n. Okay, so it's subtraction. It has to be written when it says the difference between blank and blank, just like it is. Now we'll get to, I think, the next couple pages, how subtraction can be worded a little bit differently. Okay, it's not just simply going to say the difference, and we'll get to that in a second. And where's the other one? Divided by, yes, half of a number or a number divided by 2. Half of a number or no, that's kind of an option. You could multiply by a half, so it could be like 1/2 n, or divided by 2, which would mean n divided by 2 or n over 2. You can make it look like a fraction. Those all would mean the same thing. An example of that would be like 8. If the number was 8, that was like you're using n for. If you take half of that, if you multiply by half, you get 4. 8 divided by 2 is 4. 8 over 2 is 4. So you get all the same answers. It's just when you say number divided by 2 or half of a number, you can kind of have some options there. In the same way, number 11, a number divided by 3, you can put n divided by 3, or you can put n over 3 as a fraction. Okay, because a fraction like that also means you're going to divide. Oh, there we go. That's one I wanted to go over. There it is. Number 10, 6 less than a number. Okay. Notice it doesn't say difference between two numbers. It simply says 6 less than a number. Well, that means subtraction because you're 6 less than something. But notice that the 6 is written first here, but it's actually going to be at the end of the expression. So it's actually going to be n minus 6, because think about it, you're taking 6 away from something. So the minus 6 has to be taken away from the number, which be n or x, whatever you choose. So it'd be n minus 6, not 6 minus n. And you have to kind of think that through in your head. It's not really a math thing. It's like you're taking 6 less than something. Okay? Whereas when it says the difference between, that's simply saying you're subtracting two numbers. And in the order that they're in is the way you subtract them. Here it's telling you that 6 less than something. So you start out with a number. Let's say you have $50 in your account. So you'd have 50, and then you're taking 6 less than that. You spend $6. So it'd be 50 minus 6. in that situation, you wouldn't start out with the 6 and then take away your account. So you got to kind of use your mind a little bit with the subtraction and the way they're worded, because they can be a little bit deceiving until you get used to them. Okay. 103, 104 is evaluating the expressions. Very, very basic here. You're just simply, they're giving you what the variables mean. So like for the practice there, you know, x equals 2, n equals 3, y equals 5, m equals 10. You're simply replacing the variables with what the number corresponding with them is. So number 1, x plus y. Well, as you can see there, x is equal to 2, y is equal to 5. So you just plug those numbers in. 2 plus 5 equals 7. Yes, that easy. Very basic. As you can see, they get a little bit tougher as far as they start putting parentheses in, two and three step problems. Okay, but you're still just plugging whatever the variable, the number that it represents, into the expression and just solving it. Okay, don't overthink it. Don't make it any crazier than what it is. But the rules of our order of operations do apply. So, like number 10. Notice the b plus c is in parentheses, and then it's times d. So you would do the b plus c first, it's in parentheses. So it'd be 4 plus 6, which is 10. And then that times d, which is 8, so it'd be 80 would be your final answer for that problem. And then what is really kind of get a little bit more, people get a little freaked out a little bit, is that when they start setting up into word problems, and you have to kind of pull a variable out of a word problem. Now here they're starting out, they're just getting used to this concept. So they're telling you, like, Linda spent D dollars. They're actually giving you the D for dollars. Then she spends $15 more. So how many dollars did she spend? So she spends D, and then she spends 15 more. So you're just going to add 15 to that. So it's D plus 15. And then, like, number 2, Asia is 6 inches shorter than her husband. If Asia is T inches tall, how many inches tall is her husband? So she's 6 inches shorter than her husband, okay? And how many inches tall is her husband? So you take Asia, which is T, and add 6, because the husband is taller. So he's 6 inches taller than her, so you'd have to add 6 to Asia to find his height. So it's F, T plus 6. I see, that problem confuses a lot of people because they read Asia shorter, so immediately you want to think subtraction because it's shorter, but they're giving you the variable for Asia's height, which is T. That's the variable. So to find her husband's height, you have to add 6 to Asia to get to her husband's height. So it's kind of really just carefully reading these questions. What I do, and I don't know if I've said this in the videos, and I dead serious when I say this, I draw pictures a lot. People used to I don't say marvel at me, but kind of like, what are you doing? I'd go to set up some problems like these back when I was in school, and I would literally draw a picture of whatever the problem would be. Like right there, I would draw Asia, I would draw a husband, and then I would say, okay, Asia's T, so the husband's bigger, so I'd have to add 6 to get to his height. It just, for me, sometimes drawing a picture helps to just make it visually a little more clearer for me. And I've noticed some people would say to me, like, you're right, it does help. Sometimes it seems kind of cheesy. Sometimes it seems kind of dumb. But if it helps you get the problem right, I'd rather get it right and look dumb. So as you're going through those, you might have some questions. I don't think any of these yet start using parentheses. Not yet. So they're very basic. Just, again, it's the key is just reading it and kind of understanding, what's it asking me to do? Is it asking me to add, subtract, multiply, divide? Is it 1 or 2 steps? So just be careful with the wording. I'll just keep emphasizing that problem. Now the next page is solving the equations. A lot of you probably, I would think, maybe have been to this point. You always see in the equations, you think of it as a scale. You're gonna have an equal sign most of the time. You might have a less than or equal to sign, but either way, think of it as a scale on each side. And obviously if it's an equal sign, one side has to equal the other one. So as you can see in the example, let's go to example number 1. X plus 12 equals 43. So you have a variable there and you're adding 12 to it, and equals 43. So we want to know what x equals. Now a lot of people can look right at that and say, well, I know it's 31 because I know 31 plus 12 is 43. But when you get into these larger 2-3 step problems, you want to know how to solve this without being able to just look at it and do it in your head. So how to do that is locate the variable. Okay, so in this case it's x, and these are just one-step ones. These are nice and easy. What's being done to the variable? Ask yourself. In this case, it's 12 is being added to it. Okay, so the thing is, it's being added. So you want to think the opposite. So if it's being added to, you want to do the opposite, which is subtract. Remember those inverse we talked about. So add, subtract, or inverses, multiplication divides inverses. So if it's being being added 12, you do the inverse, which is minus 12. And since we're thinking of a scale, if you subtract 12 on one side, you have to subtract 12 on the other. So just think of it like a scale. If you have a big scale set up and you take 12 pounds off one side, if you don't take 12 pounds off the other side, scales will fall. It's not going to be equal anymore. So that 12 and negative 12 cancel each other out, makes it a 0. So the only thing left on that side is the x. And then on this side, you take the 12 away from 43, you got 31. So that leaves you with x equals 31. Very, very basic. These are, again, I'd love to have a dry erase board to do this. And as you can see from the examples, now example number 3, and we'll talk about that one. As you can see, the variable now is on the right side. It's like 35 minus n. So the variable is not how a lot of times how you're used to seeing it first. It's actually now being subtracted from the 35 equals 19. Now I've told people there's 2 different ways to look at this. The book shows you here they're adding the variable to the right side first, getting it to where it's a positive variable, and then subtracting the 19. Okay, you can do that a different way. It's not shown in here, but as you can see there, the variable still has a 35 with it. Okay, what you could do is subtract the 35, and if you subtract 35 from that side, you have to subtract 35 from the other side. That 35 and minus 35 cancel each other out, but what you have left on there then is a negative n. Okay, don't forget that minus sign is there. It's a negative n, would equal negative 16. Okay, because you have 19 minus 35. When you have a negative variable, and you want to know what the variable means, that means you have to flip that sign from negative to positive. But when you flip that variable to positive, you have to flip the sign of the number on the other side. So what you'd have there is negative 9 equals negative 16. Flip the sign to the positive n, but then you have to flip the sign to the positive 16. So there again, n would equal 16. You're getting the same answer. It's just going about it like 2 different ways. I hope that makes sense verbally. I can picture it, and I wish, again, that I had the board to do it. And in example 4 and 5, it's the division multiplication. So in example 4, 3 times the variable equals 108. Again, you isolate the variable. What's being done to it? It's being multiplied by 3. You want to do the opposite, the inverse, which is divide by 3. If you divide by 3 on that side, divide by 3 on the other side, y equals 36. And in example number 5, the variable is being divided by 6. You want to do the opposite divide, which is multiply. So you multiply by 6 on both sides. The 6 times 6 cancels each other out, leaving with w, and the other side 6 times 9, 54. And again, then that page is just basically you're solving those, and most of them pretty straightforward, nothing too complicated. And then about a little more than halfway down that page in 107, you have the 2-step ones. Now, the 2-step one's it's very important. As you can see in the example, 2x plus 5 equals 15. Do the addition or subtraction first. So if it's plus 5, you want to do the minus 5 first on both sides. Some people would say, well, can I divide by 2 first? Yes, but it would make that problem a whole heck of a lot harder, because you don't just divide the variable by 2. You'd have to divide the 5 by 2 and the 15 by 2, all of them together at first, which obviously leaves you with fractions, because you're going to have 5 divided by 2, which is not even. 15 divided by 2, which is not even. And you have to work it out with all these fractions. You don't want to do that to yourself, I promise. So you subtract 5 first from both sides. That gets rid of the plus 5 minus 5, leaves you with 2x equals 10. Now you have the variable being multiplied by 2. Do the opposite, which is divide. Divide by 2 on both sides. X equals 5. Okay. And at the bottom there, like you said, you got some two-step problems. Do the addition or subtraction first, then deal with the variable second, which would be multiply or divide, the opposite. Next page is the exact same thing, like I was just saying, except it's now inequalities instead of the equal sign. You have a less than or less than or greater than or less than sign, but it is solved the exact same way. So don't think you got to change anything. Still just like the example there, m plus 5 is greater than 8. You still just subtract 5 from both sides. Gets rid of the plus 5 minus 5. M is greater than 3. Same. Solve it the exact same way. Just the only thing different is instead of an equal sign, it's a less than or greater than sign. But the rules of it don't change. You still solve it the exact same way. And then the writing the equations and inequalities, these are just one little step further than what you've done the previous page or two. Sorry, I'm having a hard time. My laptop's staying stable. Where you'll see that here is like the word is usually going to be where the equal sign goes. Or sometimes it's greater than, but usually is equal to, but it can be greater than or less than. They're usually called an equation because the signs, like I said, you're usually going to see an equal sign. Blank blank is equal to blank blank. It can be an inequality though that tells you it's not equal, that one side's greater than the other one. But they pretty much, like I said, they showed you here, they mean, or they're solved the same way. They just mean slightly different. Instead of being equal, one side's greater than the other, but they're solved again the exact same way. So when you see here, number 1, 52 is 5 greater than the number x. So 52 is, okay, so right here you can put 52 equals. 52 equals. And then 5 greater than a number x. So 5 greater than something means 5 more than something, which means you're going to add 5. What are you going to add 5 to? A number x. So 52 equals x plus 5. And as you can see there, I think we mentioned it earlier, the variable is usually going to go first. So instead of having 5 plus x, you're almost always going to see x plus 5. But we know from what we first said on the first page, x plus 5 and 5 plus x, remember, mean the exact same thing. Rules of addition. Doesn't matter which order things go in, you're going to have the same answer. So just don't worry about thinking, well, if I put 5 plus x, am I wrong? No. But on a test purposes, just like here, D would be your answer. Okay, so don't be looking for 5 plus x and be like, well, I don't see it, so I did something wrong. No, remember 5 plus x, x plus 5, same thing. Just usually you're going to see the variable first. Okay. And then number 2, so again, the wording of these can get kind of crazy. Sometimes the is right at the beginning of the problem, like number 1. Number 2, the is at the end of the problem. So here we got 4 more than 3 times the number is equal to 34. Okay. So the is 34, you can start out by writing that, even put the equal 34 down first. That kind of separates it. That way you know that side's already done. You don't have to worry about doing anything else to it. And now we'll take that first sentence, 4 more than 3 times a number. So it sounds like a lot, but you separate it into a couple different things. So 4 more than something. We just got done saying that more than is plus 4. So we know it's 4 is being added to something. Added to what? 3 times a number. So 3, I think the n for this problem, but again, it could be any variable. 3n, 4 more than that, is equal to 34. And as you can see here, even, they put the variable second, so it's f. 4 more than 3 times a number. So 4 plus 3n equals 34, so f. And again, once you start doing a handful of these, they'll become much, much easier. I know at first, like a lot of times people read it, and kind of get like, I think but once you start getting the hang of these, they're really not that bad at all. I promise. And then the last page for the just to go through with the work is 110, and that's using equations to solve the word problems. So it's basically what you just did on the last page, except instead of them telling you this times a number minus this equals this or whatever, you actually have to pull that information from a word problem and apply it. And as you can see, the example, Penny wants to go on a trip that will cost $930. She's already saved $150 for the trip. To earn the rest of the money, she took a job where she earns $12 an hour. So the question then comes in, how many hours will she have to work to earn enough money to pay for the trip? Okay, so instead of trying to write this one step and be done, pull some notes out, especially if this is something that you find a little bit tricky. Think, what's the first item that jumps out? The total cost, $930. Okay, if you know that's the grand total what we're trying to get to, you can almost start out by putting in equals $930. Boom, right off the bat, because you know that's the total we're trying to get to. What other information do we know? We know she's already saved $150. Jot that down. And then we need to think, okay, she's making $12 an hour. Jot that down. And so the key thing that's missing is how many hours does she have to work? That's the item that's missing. Therefore, that's where the variable will be. Okay, so remember the variable is always going to go with the missing information. What information am I missing for this problem? I'm missing how many hours she needs to work. So there's your n or x, whatever you decide to choose. So your equation would be the information the money saved. She's already got the 150. Boom. Plus, she's going to add that to whatever she works. And what's she working? $12 an hour times how many hours she works. So there's where the 12n comes in. So you have the 150 plus 12n, or it could be 12n plus 150, either one, is equal to 930, because that's the goal that she has to get to. So again, once it's set up, then you solve it just like you have been. You subtract the 150 from both sides. That cancels it out on the left. You're left with 12n equals 780. Now the variable is being multiplied by 12. You do the opposite, which is divide by 12, and you got to do it on both sides, which leaves you with n equals 65. She'd have to work 65 hours at $12 an hour to make enough for her trip. And again, it's always a good idea with these, if you're struggling a little bit, to check your answer. So take that 65, plug it back into the problem, do 65 times 12, add that 150 to that, and make sure it equals a 930. If you get some crazy number, that probably means something was set up wrong, or you didn't multiply right or divide right or something. So I would imagine this page takes some people to work. It takes some, I wish there was more than 6 actually of these. But again, just remember the key things. Locate the information that that's given to you. Kind of jot it and pull it out from the problem, and then apply the variable to whatever piece of information is missing. What am I missing? It's going to be as part of the question. How many hours this? How many days that? How much money this? So pull that out. That's going to be your variable, and then just be careful with your reading of like what's being added, what's being subtracted, what's being multiplied. So it just takes some getting used to. There's really no shortcuts. And then page 111 to 112 is the skills checkup, which is 20 problems. A very, very good, helpful resource to take that test, kind of a pre-test for the one I'll set up. So I guess that's all for now. Lengthy video. I know algebras can get a little dicey with some people, but like I said, this is just the intro stuff, nothing too in-depth. So, and this is the last one. Final will be next week, and it'll be a cumulative final, and it will be longer. I'll definitely give longer time on the final. I think it'll also, probably 50 questions, I would imagine, but we'll talk about that later. So hope everyone's having a great week. Be blessed, and I'll be in contact soon.